Okay, this video lecture is on Chatellier's principle and catalysts in equilibrium in a nutshell. Chatellier's principle. Pardon my pronunciation, but as a West Coast American, I think my French pronunciation is probably worse than my Korean pronunciation. Anyways, Chatellier's principle is this, which basically just says that we can change the conditions of a system at equilibrium and it will respond by shifting itself to the left or the right, whichever way that will counteract the changes we made. Now let's see exactly what that means concretely. Le Chatelier's principle regarding concentration. We can change the concentration of a product or reactant in a system simply by adding or removing more of that product or reactant. If you add reactant, the system will then use up some of it by shifting its equilibrium to the right, and the equilibrium constant though will stay the same. Conversely, if you take away some product, the system will then make more of the product by shifting to the right, again shifting to the right, and it still will keep its equilibrium constant. Now, both of these, adding reactant or taking away some product, the system will respond by shifting to the right, and then we can also go to the left. If you take away some reactant, the system will then make more of it by shifting to the left, and yet again, the equilibrium constant Kc stays the same. Also, if you add product, the system will use some of that extra product by shifting to the left, and of course, Kc stays the same. Now here, by taking away a reactant or adding product, we're moving to the left, or rather we're forcing the system at equilibrium to move to the left to reestablish its new equilibrium with the same Kc, mind you. How about with pressure? Now, here's an example of a reaction or an equilibrium that involves some moles of gas. More specifically, it involves a different number of moles of gas on the left and the right-hand side. In this particular case, there's only moles of gas, 1 mole of gas on the right-hand side, the 1 mole of carbon dioxide, and there are no gas moles or gas molecules on the left side of equilibrium. If we have anything like this, where there are different number of moles of gas on the left or right side, then pressure can affect the equilibrium. If you increase the pressure, the system will relieve it or try to relieve the extra pressure by shifting to the side with less moles of gas. So in this reaction example reaction, if we increase the pressure, the equilibrium system will respond by shifting equilibrium to the left where there are less moles of gas, and the Kc stays the same. Conversely, if you decrease the pressure, the system will replenish that missing pressure by shifting to the side with more moles of gas. In this case, it'll move to the right side to be making more carbon dioxide to make up, so-called, make up for the missing pressure. And again, the equilibrium constant will remain the same. And again, increasing pressure, less moles of gas. Decrease the pressure, the equilibrium shifts to the side with more moles of gas to make up for it. Again, what you do, and then the system shifts left or right to try to counteract what we've done. Okay, let's consider temperature. Now here we have nitrogen and oxygen combining to make nitric oxide. And as you can see, the forward reaction in here has a positive delta H, which means the forward reaction is endothermic. It takes heat for this reaction to happen, which of course means, like all equilibriums, the reverse reaction has the exact same delta H, but the opposite sign. So the opposite, the back reaction, nitrous oxide breaking up into nitrogen and oxygen gas, has a negative delta enthalpy of 181 kilojoules per mole. So if you take a system like this and you raise the temperature, the system will use that extra energy from having a higher temperature to shift direction in the endothermic direction, which in this case is the forward reaction. And Kc will have a new value. Now this is different. When you change temperature, you get a different value for Kc. If you lower the temperature, then the system will try to restore it, so to speak, by shifting in the direction that is exothermic. In other words, it'll create more heat to make up for what you took away. And in this case, the back reaction is the one that's emphasized as it seeks a new equilibrium at a new Kc value again. So we have raising the temperature, and then the system shifts to the endothermic side. If you lower the temperature, the system counteracts what you've done by shifting to the exothermic side. What about catalysts? Catalysts do not shift equilibriums, nor do they change equilibrium constants. Catalysts only speed up reactions. In an equilibrium, they speed up both the forward and back reactions the same. Therefore, a catalyst will just make a reaction find equilibrium faster. Okay, let's summarize those things we've learned. 4 things. The effects of concentration. It changes the position of equilibrium, and there's no change in the value of the equilibrium constant. Pressure changes the position of equilibrium, but only if we're talking about an equilibrium reaction that has a different number of moles of gas on each side. And yes, changing pressure does not change the value of Kc. Temperature changes the position of equilibrium, of course, and it also changes the value of Kc. And last, a catalyst. No change on position of equilibrium and no change on the value of Kc. To summarize, the first 3, concentration, pressure, and temperature, all change the position of equilibrium, whereas the catalyst has no change. Conversely, temperature is the only thing that changes the value of Kc. Everything else has no effect on the value of Kc. Let's summarize. Ready, set, go. Le Chatelier's principle, which basically just says that if we do something to a system in equilibrium, it will respond and try to counteract what we changed by shifting to the left or right as needed. We considered the effect of 4 things on equilibrium. The first, concentration, changes the position of equilibrium but does not change the value of Kc. Pressure changes the position of equilibrium, but only if the reaction has a different number of moles of gas on each side, and also does not change the value of Kc. Temperature changes the position of equilibrium and changes the value of Kc. A catalyst has no change on the position of equilibrium or the value of Kc. So one more time, concentration, pressure, temperature change the position of equilibrium, catalyst no change. Temperature is the only thing that changes the value of Kc. Everything else has no effect on the value of Kc. The end. Say goodbye, Manji. Thank you.